Say we have these 4 abstract IKEA birds, and we want to order them by height from shortest to tallest. Using insertion sort, this can be done easily. Insertion sort begins with the second item in the list, and then compares all previous items, and then continues. So, if we start with this very tall bird, which is the second item in the list, we see the bird to its left is much shorter, so it is currently in the correct place. We then move to the next bird, which we can see is much shorter than the bird to its left, so we swap these 2 birds. Comparing the same bird again, we see the bird to its left is slightly shorter, so it is in the correct position. Finally, we move to the last bird, which we see is very much shorter than the bird to its left, so we swap them. Again, it is shorter than the left bird, so we swap again. And then one final time to achieve the ordered list of birds. Beautiful. As you can see, insertion sort works very well with a few items in a list. If we were to increase the amount of items though, the amount of comparisons would drastically increase, since every item in the array must be looked at, and since every item before that item must be compared to it, insertion sort doesn't work well with larger lists.
Alrighty, so first up is whether or not this particular algorithm is an in-place sorting. And it is. You know this by the fact that let's start with number 4 here first. It goes through and compares it to the one before it. And since there is no one before it, nothing changes here. So then it goes under 2. And then once it's at 2, it compares it to the one before it and sees if it's smaller. If it is smaller, it will then move 2 to where 4 is, and then move 4 back. So it doesn't need to use any other space. It just moves 1 back and moves the other one ahead. And the same thing happens for each other number. So it compares this one, the one before, and then adjusts as necessary. So in that sense, it is an in-place sorting algorithm. Whether or not it is stable refers to whether or not matching numbers, for example, these 2, go back to the original setup of the array. So if this one were black, when going through the sorting array, the result you get when you end up with the fully sorted thing would have them in the same order as originally. Then it is stable. Here you can see that these 2 were in the same order that they were when I first made this, which was black in the first one, blue in the second. So is it stable? Also yes. Now, when it comes to runtime, the best case scenario would be they were already in the order you see here, this one. However, in the worst case scenario, it would be 4, 3, 2, 2, 1. In the first case, it would just go through checking each one, and if they're all in the right order, the time is O of n. However, if they're in opposite order, they're going to have to go back through one, this one wouldn't move at all. However, this one would have to move 1 space, this one would have to move 2, this one would have to move 3, and this one would have to move 4. So in that sense, it would be, instead of the best, which would be O of n, the worst would be O of n squared. as it has to go through and first check each one. So this would be check once and then move nothing. This would be check 2 and then move 1. And this would be check, like go 3, 2 over here, and then go just as many back. And then so on and so forth. You go forward as many spaces as you have to go backwards, which means it's the maximum amount of time you'd have to employ to get them all properly sorted.
Here's an example of an insertion sort function in C++ provided by geeksforgeeks.com. This function has two parameters, the array itself and the size of the array, n. It then loops through each index of the array, setting a variable key to the current element being sorted, starting from 1, and variable j, which is the previous element in the array. The code then iterates backwards starting from j, where it checks if the previous value is larger than the current value, and if it is, moves the previous value forward. After this is not true, the current value, i.e. j plus 1, is set to be the key. This continues with the next element in the array until the entire list is sorted. What's something special or unique or way cool about insertion sort, Yarrington may ask? Simple. No, I mean, it's simple. Insertion sort when used on a small list just works. Or if a list is large and mostly sorted, it just works. It's easy and it's relatively fast with these kinds of things. Insertion sort is straight trash, awful garbage when used on any large list though, which I find kind of funny. That's it.
What you know about rolling down